Hey, are you lacking any inspiration right now in the AEC profession?
I guess so.
Well, I've got a killer episode for you. This episode is a good friend of mine, Stoney Londono, and he's a mechanical engineer. And the episode is called De Donde Eres, which gives a hint to his origin and his background. And toward the end of the episode, we really get into some inspirational aspects. So we're going to discuss that, but we're also going to go into what he does. He's a mechanical engineer, MEP, mechanical, electrical, and plumbing. And we really get into the nuts and bolts of what a mechanical does and so forth. And also some of the specific aspects of the Lowcountry where we are, like the humidity and other things. So we're going to learn, we're going to get inspired, and we're going to have a good time too. We have a few laughs. So it's a good episode. You may have to stick around toward the end for the inspirational part, but the other parts will be very educational and also entertainment as well. So that's what we have to look forward to today. My name is Andy Richardson. I've been doing this 26 years as a structural engineer. And I'm on a journey right now still to learn more about the AEC industry. What are architects, engineers, and contractors across the aisle? What are they doing? And what can I learn from them? And I'm doing interviews with other professionals to find out more about them and also why they're doing what they're doing. So I want you to come along with me on that journey. Let's get started.
Welcome to EHANCE, an AEC podcast where we learn the why behind AEC professionals so that you can learn your why.
So the first thing I want to ask you, Stoney, is ¿De dónde eres?
De Donde, Eres. So I was born in the mountains of Colombia, a small city, well, actually a medium-sized city called Pereira, right in the middle of the country, in the just the perfect tropical weather, 75 degrees all day long, a little bit of rain here and there, but beautiful mountains. And so that's where I'm from.
Okay, awesome. And did you know you were going to be like an engineer growing up? Was that something that you had aspired to be, or?
No, I wanted to be a pilot or an astronaut, but along I guess, the science lines, but never thought, because maybe later we'll discuss this part of mechanical engineering is a part that nobody knows about. So I kind of ended up doing this almost by accident.
Right. Okay. So, yeah, tell us a little bit about like how a little bit about your background and then how you got into mechanical engineering.
So I came to this country when I was 17 years old, actually 16 years old, and my mother had lived here quite a while before I came to live with her. I was living with my father after they divorced, and I went and lived in New York City for 8 months. Right away, I went to a English as a second language school. And for 8 months, I went to a English as a second language school. And then one day on TV, I saw a commercial for the Harriers in the Marine Corps. And back in those days, you would send a postcard. There was no interwebs. So you sent the postcard, and 2 weeks later, the recruiter was at my house. The recruiter called my house, and he was at our door. And then I think 2 months later, I was on my way to Paris Island. So that's how I ended up in Beaufort, South Carolina.
Okay. Now, there's a couple things. So, yeah, that's a little bit of an ongoing joke we have about the interwebs. For one thing, maybe some people may not get that joke. But the other thing is Paris Island, South Carolina. So that's, for those of you that may not know, that's where they make Marines, at least on the East Coast. There's 2 bases. So he went through Paris Island, South Carolina, and went through boot camp, right?
Right. So then I left for 4 months. I went to my trade school for the Marines in Lakehurst, New Jersey, and then they sent me back here. And I spent the 5 years of my Marine Corps career basically in Beaufort, except for a few deployments. I spent 9 months overseas, and then pretty much here the rest of the time. But the whole time, back to how I ended up in engineering, if you're good at math, somebody's always telling you that's what you should be. And I always enjoyed math, and it was easy. It came easy to me. So, but I decided to become a mechanical engineer after I left the Marine Corps. And at that point, I already had a family. And so I commuted to Columbia from Beaufort to class.
Yeah. So the Columbia to Columbia connection. So.
Right. I went to, and that's one of the things when I say, people ask me where I'm from, I always say from Columbia, the country, because if I don't say that, people who grew up in Columbia, the city, will say, "Oh, really? What school did you go to?" Or or do you know this place? But I always have to say Columbia, the country, here in South Carolina. My dream, though, is a mechanical engineer, because the construction side of mechanical engineer is something nobody thinks mechanical engineers are part of. So I was going to school, working part-time. I was a bridge operator down the street.
Mm-hmm.
And while I was going to school, and then I started working for an architect here in town, Allison Ramsey Architects.
Okay.
And then because they did some commercial work, I met a mechanical engineer, and that's how I eventually, after graduation, I started working for him. And that's how I ended up in this part of the mechanical engineering industry.
Yeah, but stayed in Beaufort, right here where Paris Island
Right.
is.
Well, the whole time in school, the dream was to design the latest Corvette transmission as a mechanical engineer. That's kind of where my or the next jet engine for McDonnell Douglas or whoever it is. But having a family, it kind of just, there was a job available, that the things lined up, and I ended up working in mechanical engineering in the construction side of the business.
Right. And and by the way, so this episode and really the podcast as a whole, I mean, the audience is people in the AEC community at large. So, but that includes architects, other engineers, mechanical, electrical, but there might be mechanical that are working on Corvettes, but most of them are in the AEC community, the building community. But you may have architects or contractors that don't really know what an MEP engineer do, or don't really understand. In fact, I'm a structural engineer. I don't understand a lot of what you guys do. So maybe help understand a little bit about that a little. Like, what does and you're doing all three, right? You're
right. So this engineer that I started working for, I went to work for them as a mechanical engineer, and he was an electrical engineer. So through the 12 years working with him, I learned the electrical side of engineering. So, and the firm I worked for, we did mechanical, electrical, and plumbing. We dabble in structural for a little bit, but we decided best to leave it. We had a structural engineer in-house, but we decided best to leave it.
Yeah. Now, there's a funny story behind that. We may have to come back to that one.
Anyway, so I'm trained as a mechanical engineer. I spent 12 years working for an electrical engineer, and that's how I picked up that side of the. And so when I went out on my own, my company is we do all three services. So mechanical, it's basically the HVAC part of the business, heating, ventilation, and air conditioning, which it's sort of the most complicated part of the three for us because of where we are, high humidity, and each building is different. There's many factors, in my opinion, that make the mechanical part the more complicated of the three. Then we do plumbing engineering. We don't do steam, but we do sewer and sanitary sewer and water distribution. And then on the electrical side, we do power and lighting for commercial buildings. So my niche is medium to small commercial buildings. We do a little bit of residential here and there, mainly for mansions, large size homes, and sometimes it's it's funny. It's for a retired engineer usually, because for some reason they want their house to be designed by an engineer. So that's sort of what we do: mechanical, electrical, and plumbing.
Okay, and the mechanical tends to be the more challenging, And
Yeah.
I know, like, one thing we've talked a lot about is, of course, we're in the South, so that's a challenge probably. But
Right.
then also,
It's humid. Well, not just the South, but hot and humid conditions makes it a challenge for certain types of buildings.
Yeah, and then also, you do a lot of kitchens, I think, right?
We do a lot of restaurants. Yes.
Yeah, restaurants.
Yeah. So that's a challenge in itself, because a restaurant, it's a system, not just, everything that goes into a restaurant is part of the HVAC design. And so it's a system that has to work together. The exhaust hood and the makeup air fans and the air conditioning and all this has to work together for the system to work right.
Yeah. In fact, there was a job recently you were telling me about where you may want to elaborate into that. Like it had too much air conditioning originally from a different engineer, and then you redesigned it. Yeah, I mean, you may not want to give the specifics, but
Right. It wasn't a kitchen; it was actually a supermarket where it turns out the refrigeration equipment in the space contributes to the cooling load, and so if it's not accounted for right, it can create other problems. The problem with air conditioning is that too much is bad. More is not better, I guess is the right way to say it. More is not better. Maybe a bigger beam is not necessarily better, but it's not worse.
Yeah.
But in air conditioning, more is actually worse.
Okay, yeah. Can you explain? Because I think that's interesting to me, because I mean, I've understand what you're talking about, like the short cycling, I think you call it.
Right.
Yeah, explain that.
So
we're kind of getting, the part of it is like, we want to get into some real depth on certain aspects, and then we want to get into some why stuff too. But this is the type of stuff I want to do. It's just like talk about the granular. So yeah, get into that a little bit, if you don't mind.
So the industry standard is to design for 95% of the time. There'll be times, and it just happened in the past 2 weeks, the two hottest weeks of the year. We don't design for those. We design for 95 degree here in South Carolina.
Yeah.
So on the 105 degree days, your building is going to be a little warmer. But if we were to design for those 2 weeks or whatever the time length is, it would be a more expensive system. And it would also, unless it's a sophisticated system, that then there'd be problems in the mild months, the middle of April when it's just 75 degrees, but it's humid, and later in the fall when the same condition occurs. So the short cycling we're talking about is if too much air conditioning in a building will cool the building too quickly. And that's not a good thing, because first of all, the system turns on and off very often, which shortens the life of the system. Then the bigger problem is we're trying to do 2 things in the hot, humid weather. We're trying to meet temperature, and we're trying to meet humidity requirements. So what happens when it short cycles, the system doesn't have the time to remove the moisture out of the air. And so it creates for although cool building, but humid building. And it turns out the humidity, it's a big part of the comfort. So if the humidity is too high, even though the temperature has been met, the comfort is not there. Mm-hmm. And then you can create other conditions. Moisture accumulation will lead to mold and other stuff.
Yeah. Okay. And there's truth in the old adage of it's not the heat, it's the humidity. Is that what you're saying?
Right.
Is that part of it?
There was a phrase somebody said in a conference, and I always forget it. But yeah, it's the corresponding dew point or something. It was a joke, but I couldn't remember it. But
okay.
Yeah.
So the humidity is important. The short cycling. So you need a good mechanical engineer, and you need a good electrical and plumbing engineer as well. So I guess.
So back to that for a second. I call it highway miles. When you're trying to buy a car with high miles, but they're highway miles. They're not city miles. The idea is that you're not stopping and going all the time, which is bad for the engine. Same with the air conditioning. In the middle of summer, you want this thing running. When it's 100 degrees, even though we designed for 95, the thing is going to run, but you want to run it all the time. Because it's doing its job. It's cooling and also removing all this moisture. Yeah. So highway miles is what I call it.
Meaning it's good mileage.
Meaning, right. You want the system running for long periods of time instead of 5 minutes every 10 minutes for an hour.
Yeah. And another thing too, people are really interested in, energy and those type of things. Like right now with the technology we have, I mean, when I built our house, I guess about almost 20 years ago, I don't remember they call it the SEER rating, right? It seems like it was like a SEER 11, but now we're up to, what are we up to now?
13 is the minimum, but code minimum is not the best. You want to do better. The higher the SEER, the better efficient the system is.
Yeah.
The industry has evolved to the point where you can get to the nth degree of sophistication and you can create whatever system you want or buy whatever system you want. It's just a matter of what your budget will allow. So you can design for those 105-degree days.
Yeah.
It's just whether your budget will allow it, and you also still have to meet the energy requirements, not just the energy requirements of the code is what I mean. Not just the energy requirements of you don't want to pay too much electricity. You have to be energy efficient per the International Energy Conservation Code. So you got to find a balance in there somewhere.
So, but for those watching, by the way, we didn't schedule the construction to be going on in our adjacent room here, but I guess that's the nature of construction, right? So we're in an AEC podcast, EHANCE AEC podcast, and obviously they're doing construction right outside, so that's the nature of it. But so let's dig into a few other things, Stoney. I guess one question is maybe a project that you're working on that's interesting. Do you have an interesting project that maybe you want to share some specifics about?
Well, that one that you mentioned, because it's that's one of the more challenging projects, because we're chasing this dew point. We're trying to find out. So the problem in this building is that the coolers are sweating. And it's twofold. Number one, if you're trying to look into the meat cooler, you can't see the meat,
right?
Because there's condensation on the glass. And the second part of it is that there's so much condensation that's dripping on the floor. So we are trying to chase the temperature and the dew point at which the coolers no longer sweat.
Okay.
So it's been an ongoing thing, and there's a very good HVAC contractor working on that. He's taking measurements every day, and he's doing all we can to find. We need to find the relative humidity in the space at which the coolers won't sweat.
Okay.
So it's pretty interesting. Now we're getting into the science of the thing.
And some of that has to do with our local conditions here in South Carolina, or
right? Yeah. The humidity outside and relative humidity, it's relative. It's sort of the amount of water that air can carry at certain temperatures. So at the temperature we want to be, we can only have so much water in the air. And if we want to maintain 75 degrees in the space, we're trying to figure out what the relative humidity, the maximum relative humidity has to be.
Yeah. We're going to take a pause for station identification. I'll be right back. All right. Well, so we're back from the station identification.
That reminds me of, so in the summer, I would take classes and I would drive to Columbia, and I took a statistics class in the math building at USC. And so they were doing construction while we were in the statistics class. And I had been a Marine. I left the Marine Corps. I was in my mid-20s by then, in a classroom of 18-year-olds and the professor. And then we are in a class and they're hammering and they're sawing and they're banging next door.
Yeah.
And the professor didn't know what to do. And like, I said, man, I wish we could, he says, I wish somebody would go over there and tell him to stop. So I just got up and went over there and said, hey, you guys need to stop. We're in the middle of class. And the professor chased me down because he was worried that, these guys were going to be like, no way. But, they were very nice and they left. They stopped. They went on a break.
Yeah.
But yeah, it was worse than this, actually.
Yeah. Well, it wasn't too bad, and I hope I wasn't too rude to him. But it's just kind of like the worst possible time.
Perfect timing. Perfect timing. All right. Well, so that was a challenging project. I don't know. I got distracted. Did we finish that one, or did no? I think we're trying to figure out. The manufacturer tells us that a 55 dry wet bulb temperature and 75 degree dry bulb temperature. That the coolers shouldn't sweat, but they are sweating at that. So now we're trying to find the real number where the coolers won't sweat. So that's a challenging project for me. It's fun because we're in the middle. We're doing the math, and a lot of times the projects don't require this level of math or hand calculations.
Yeah.
This is beyond the software. Now we're outside the software, doing it by hand and going back to the things we learned. All the challenging projects for me are churches, for instance. Churches. Yeah. I do a lot of medium to small size churches. A church is a challenge because it's mostly unoccupied for 95% of the time.
Right.
And then for 3 hours on Sunday is full. It may not be full every Sunday, but come Easter, it's overflowing. Right. and the way
and it's a hot time of year too, right? Like it's starting to heat up at least.
It's not necessarily hottest, but there's the moisture challenge. The biggest thing with HVAC for us here in this hot, humid weather is the moisture. But it's a challenge because we design for worst case, 95 degrees, and 80% relative humidity. But that doesn't occur, in a full building.
Right.
But so now for 95% of the time, we have too much air conditioning.
Right.
In a church, which
if you're not careful, right?
Right.
Like if
you don't do it right. So that's a challenge.
Yeah.
So that's a challenging project for us. Restaurants, always challenging. There's a hood. There's you got to blow air out, and you got to make it up. You got to bring it in at a certain temperature per code, and then you have a bunch of people. Mm-hmm. And it's occupied at night. It's full between 6 and 8.
Yeah.
But that's not the highest load. So, that's another challenge one for us.
Well, and also like you're coordinating between the architect, the contractor, the owner. There's cost implication. There's code implication.
Right.
I mean, these things you're talking about, and I'm not mechanical, but from us talking before and my knowledge of it, like the code has a minimum. There's minimum aspects, but on the other hand, you get the old thing of, well, why are we doing this? Why are we doing this? Like in the church scenario or in the restaurant scenario, why are we doing this huge, HVAC system when, quote unquote, we've always done it another way?
Right. That's that's one of the challenges. You have, and not to speak ill of anyone, but you have guys who've been doing things for 50 years, and our church. we did air conditioning for our church 30 years ago with this, and it worked just fine.
Sure.
Why are we doing it with that, which is more expensive or bigger? So now the architectural challenge: where are we going to put this thing, or where are we going to put this thing outside where is not? This thing is ugly. How do we? There's all kinds of coordinations that have to take place with the contractors because we can sit in an office and come up with the perfect design in our minds,
Right.
but then we find out that the machine is not available that we thought, or there's a shortage of they don't make that electrical panel. It'll be a 42-week lead time before we get it. There's challenges with the contractors, with the architects, with the other engineers. I have to get a piece of duct from this side of the building to that side of the building, but I have to cross across his beam. So now he has to plan for. I have to coordinate with him, so he has to plan for an opening in a truss, let's say, so that we can get a 20-inch duct to the other side of the building, so we can get the air.
That's the thing I know about mechanical engineering is you guys put holes in my beams. So, well, the first job we met on Hilton Head Island, it was in 2003. I don't know if you remember that.
Is it the Maniotis building?
Yeah, the Maniotis. We met, and I remember because we had to coordinate and get his ductwork. It was obviously not his ductwork, but through my beams. Again, not my beams. But so that was the first time I met Stoney. Was back 20 something years ago. So that was
a residential multifamily project, and those are a little more challenging because you don't have the luxury of a lot of space in the ceiling. In this building, for instance, we have 3 to 4 feet in the ceiling, and we can put anything we want in there. But of course, we can't do that in a residential setting because you can't have 4 feet of space between floors and for all the mechanical. So that's another challenge.
Right.
It's an architecture challenge, and it's also an engineering challenge between us, the mechanical guys, and the structural guys.
Yeah.
How do we squeeze all of that inside of a tiny space? It's sort of how you look at the engine in a new car. There's a million things in there, and you can never get to them, but they're in there.
Well, and also you're doing that. That's the design, but then also it's what we were talking about a minute ago, which is communicating with these other trades. The contractor, the architect, the structural, everybody involved. Not to mention the owner, which may be like a board for the purpose of a church, for example. So these are challenges. How do you navigate all that?
Well, it's communication with from the beginning with everybody, really. First, we find the needs of the clients and the wants of the clients. Oftentimes, the client has done this before, and we like it when it's their second or third building, and we know what they liked in the first building and what they didn't like. Mm-hmm. So that's one way of doing it, communicating with them. It's nice if there's already a construction team, because we can communicate with them and find out. They can tell as well, we don't like X, we like Y. That we prefer to work with this, and then of course if it's code, if it complies with code, we don't have a problem with it. So coordinating with the trades is really big. I've designed, ever since COVID, especially, I've designed a bunch of buildings where the electrician has come back to us and say, "Hey, we can't do that 1200 amp disconnect because it's a 42-week lead or whatever." So communications are really a big part of that from the beginning, especially with the client. Because in the end, if he's happy, everybody's happy.
Yeah, that's true.
And I like the way I like, and I think it's the last guy I worked for. He said, if our systems, if you don't know they're there, we did our job. Nobody cares about the air conditioning until it doesn't work. Right?
Right. Yeah.
Nobody cares about same with the electrical. If you plug in your computer and it works, everybody's happy.
Right.
But if there's breakers popping all the time, then there's a problem. So we want to make sure to make the client happy, and that he never has to worry about our systems.
Right.
Until the machine,
until
the machine fails, which eventually will happen. A water heater will fail. in 10 years, and air conditioning will fail in 15 years.
Yeah.
But that's the nature of it. But other than that, we want zero. And then there's a little bit of engineering. We put a little fat in it just to make sure, but not too much, because more isn't always better.
Well, some people think we over-engineer everything, right?
That's true. I imagine you hear that, like, oh, we don't need that 12-inch beam. I've been doing it with a 6-inch beam for 30 years. Right?
Exactly. So that's part of it. All right. So let's go a little to the lighter side briefly, since we've been talking a lot of technical. So, thinking about whether it's, we went over an example earlier of a funny story, but maybe you have another story that you could share, or a scenario that you could share that happened in work or in engineering over your career, something that maybe the audience would like to hear.
A funny story. Well, okay, I want to talk about our structural engineer then. Our structural, we decided to get into the structural engineering because it turns out clients like somebody who they can buy all the services in one place.
Yeah.
A client would prefer to have an architect, a structural engineer, and an MEP, a mechanical engineer, and electrical engineer in the same place. That way he's not going to 3 places. So we thought then that it would be a good idea, and we found an engineer who was looking, but this guy came from industry, from the manufacturing industry, where you can just design whatever and tell the guys in the shop and they'll build it for you, and they won't ask questions.
Right.
If the engineer says okay, then it's okay. So we thought he knew what he was doing. And so we did this restaurant, and I don't know the name of the exact creek, but it's right at the bridge between Bluffton and Hilton Head.
Okay.
It's on the right. It's on this big giant piers, and he designed those piers, concrete.
Yeah.
And we get a phone call that the builders are out there like, hey, we have so much rebar in this pier that there's no room for concrete.
Wow. Okay.
So,
And was he around still, or
he was still around. He was still around. He was, structural engineers, they're a unique bunch, but he was unique among, he was rare, but among even more unique, unique people. He lived in not Aiken. He lived somewhere in Georgia. He drove down here, and he spent the week at a short-term rental or hotel. Yeah. He got a room for the week, and
like the Econo Lodge type thing.
Yeah.
And
then he went back.
Yeah.
And I think, he lost money on working for us.
Yeah, because he was spending all his money on a hotel room, right?
Yeah. Right.
And driving.
And all this. So And then last I heard, he was driving. He left engineering. He was driving water truck. The water Culligan, the Culligan truck. He said, "Forget this engineering business." He was driving the Culligan trucks, and I think I have a friend who I went to school with. I drove to school with.
Yeah,
you met, and last I heard from him, he may have passed away. But
oh wow, okay.
The part is that it was very. We got into something we didn't know much about with a guy who probably knew less than us, and so it just became a nightmare. Yeah,
and that's just funny. He went and drove a water truck after.
Yeah,
I guess it drove him to that point.
Engineering drove him to forget this zero. I want to think about zero.
Yeah, and some days I think I feel like that too.
Yeah. It's a line in Top Gun that says, what's that trucking company? Remember when Goose says to Maverick, "Hey, what's that trucking company?" When he thought they were about to get kicked out of Top Gun school. Oh
yeah. That might be us if we're not careful. Right?
Yeah.
All right. Well, let's go a little deeper now, and wanted to find out, because the purpose of the show really, EHANCE, is to understand, obviously a little bit about you, your background, what you're doing, but also, and you always have a funny story or two, but really want to answer the why question. you actually gave me the great video from Simon Sinek, right?
Right.
Remember that?
Yeah, I remember
and
that.
he talks about your why. And so this is kind of similar to that. Like why, this is the genesis of the podcast, the core of the podcast, which is why are we doing what we're doing? You know, what gets you up in the morning? And what are you doing to create 1% better for the world? And it sounds a little bit hokey maybe to some, but to me, it gives us a why. Why are we doing what we're doing? So do you have something like that helps drive you and push you in what you do and like vision for what you're doing each day?
I think I couldn't put it in a sentence. You know, something drives me, obviously. And it's just, you know, beyond doing something that provides for my family, obviously.
Mm-hmm.
But the why, I think, has to be beyond that. I just want to, I don't know that I'm making the world better. I want to do better for my client.
Mm-hmm.
I'm trying to provide the best product for my clients so that they can be better.
Yeah.
Right. So I'm taking that. So engineers are supposed to be problem solvers. You know, I'm
Right.
taking away their problems so that they concentrate on doing what they do best.
Mm-hmm.
So they don't have to worry about the things that I do. So that's kind of the way I see it. I don't know that I could write a paragraph and say it eloquently, but yeah.
I thought that was very good. And who are you? I mean, are you working for architects normally, or?
I would say 75% of my clients are architects.
Yeah.
About 20% are builders. And then 5% is directly the owner that comes to me, somebody who knows me, like, hey, I want you to do this.
Yeah.
I'm doing this building, but I want you to do this because I've seen what you've done here and there. I've been doing this in Beaufort County for 25 years now.
Yeah.
I graduated in 1999 and started doing engineering for 25 years. So I've done enough projects that people know me. And there's enough of a sample of what I've done that some people like it, and that's how they come to me. I have clients that I've had for the entire 25 years. They stay loyal to me, and I have clients, one-time clients, and that just doing one project in their lifetime. But the majority is architects.
Yeah. Okay.
And we, you know. Beaufort, Bluffton, and Hilton Head is the majority of where my clients are, and so the work.
And working for architects, like with your why statement, and the way you phrased it, because it's we're not directly we're working for them, right? We're working for the architect,
right. And
we're holding them up. We're supporting them in their decision making. So that's part of what we're trying to do too. Is it's not just the building, but we're also helping coach and guide we're the consultants to the architect in that scenario, right? So that's part of what you're doing as well, right?
Right.
Yeah. Okay.
So a building, it's a system of, it's everything that has to work together. So we're this little part that makes that pretty building work.
Yeah. And I'm in the same boat. I mean, we're structural. So my goal is, most of my clients are architects as well. So my goal is to get out of the way. Like you said earlier, they shouldn't really have to think about what we do. It should be easy for them. So that's one thing we can do, is just that. And enhance means a lot of things to a lot of people, right? Like for you, I think that was a great way to say it. But for others, it may mean something different. And so it's a generic way. So moving into just, this is your opportunity to tell a contractor or an architect across the aisle, what's one thing that would help them moving forward? maybe it's a contractor or architect, or
To mean advice from an engineer
yeah,
to somebody who's not an engineer?
across the aisle, what's one thing that might help an architect or contractor, or one thing they might not know about what you do that would help benefit their work each day?
Plan for us.
Yeah.
Plan for us, meaning there are some big pieces of equipment that you have to account for.
Mm-hmm.
And in the effort to make the spaces bigger, and I think it gets overlooked. Sometimes it gets overlooked, the things that we have to put in the building to make it work.
Mm-hmm.
I think that's my only advice. I don't want to step out of my lane too much.
Right. Well, yeah, this is an opportunity.
But we don't design. We're trying to be conscious of all the things, especially cost. Cost drives everything. The things we select, we take into account. We're trying to meet the code, so we're not selecting this expensive piece of equipment because we're getting the kickback like the doctor would for that medicine, right?
Right.
We're designing the best way we know how.
Mm-hmm.
There is other ways. I mean, we're always communicate with us. We're always willing to talk and reconsider our thinking.
Sure.
Because we're always learning. In the end, if we're meeting the code, and if when you hit that switch, the light comes on, then we're happy. It matters, but we're flexible about how we get there.
Yeah.
There's room needs a certain amount of air to stay cool in the summer. If we can deliver the amount of air, we're happy. Just there's many ways of doing it. We propose a way, but we're flexible. And so I guess, that would be one of our qualities, I think. We're flexible.
Okay. Like flexible duck, kind of, right?
Right. Flexible like that. No, but somebody reached out to me. Funny, it's a church. Somebody reached out to me because somebody designed a church with very expensive equipment.
Okay.
But he's not willing to come off of that. Like, hey, we can't afford these machines are $50,000 each. There's other ways of doing it. So somebody reached out to me, hey, could you give us an alternate design? And I'm always conscious of not criticizing other engineers
Mm-hmm.
and their designs because I don't know what the parameters were when that design was developed.
Sure.
But when they reach out, I could. It turns out this engineer is not flexible. He's stuck on that.
Mm.
This is the way it is, and I'm not changing it. I feel I have an obligation to the client to meet all his needs.
Mm-hmm.
Not just make the building work, but a building that he can afford. So in this case, the building will probably work, but he can't afford to build that building. So then if you over-design, and I'm not saying that's the case in this situation, but if you over-design a building, it'll never get built. So it's all this effort was for nothing. And the client didn't get what he wanted.
Yeah. So
what was the question?
Something to tell an architect. I think that really helps.
No, I like being flexible.
Yeah.
It helps. So at least be approachable. Why are we doing that? So, and I can explain it. This is why we're doing it.
Right.
If I guess I would say, if your contractor can suggest a way that still will meet code and meet your needs, then I'm happy to hear it. Mm-hmm. Because I don't know everything. So I try to be flexible that way. And I try to be approachable so that there's contractors who call me about other projects, not mine, like, hey, this guy's doing this, but he won't tell me why. What do you think? So I want to be approachable and flexible.
Right. Okay. I mean, that's I think that's a really good quality. All right, let's go to a different aspect, and that's Stoney from, I don't know, a long time ago, the young Stoney. What would you tell him about your career, about life, just anything like if you had to give him advice, what would you tell him?
Buy Apple.
I guess focus on the career. What would
On
you
the
tell him?
career. Interesting. I've been blessed. I've been blessed. The opportunity has always been there, and just to not ignore or to not overlook that, or to be more grateful. It's I don't know. Work harder. It's hard to say. I've been very blessed. Truly, I've lived the American dream from a little kid in the mountains of South America. We weren't poor in the beginning, but my dad decided to be poor.
Yeah.
As he got older, and so we always had a roof over our head, and we always had a decent and all of that. But I've worked my way up, and never, I guess, regret. I don't know. That's the word. Never, always, all the challenges. I figure out a way to overcome the challenges.
Yeah.
I had a family, but I wanted to go to school. Well, so I got a job working at midnight so that I can drive to school.
Yeah.
I don't know. I've been blessed. I haven't probably taken full advantage of all the opportunities. Nobody has. But I've been lucky enough and blessed enough that I was able to turn from nothing to at least somebody who can provide for my family.
Yeah. I mean, it's an amazing story, really. I mean, a lot of people don't know this. Like, you came to the U.S., you learned our language, obviously, but you were in the Marine Corps, and you weren't a citizen at that time.
Right. So
and I didn't know that, but they'll let you be a Marine, quote unquote, but you can be in the Marine Corps and you don't have to be a citizen. I mean, you were here legally, of course, right?
I was legal. I was a legal immigrant. I came through the airport. So back then, it was more difficult to just come into the country.
Right.
I mean, people were still jumping the border and all of that, but it took about 2 years. It was an ugly divorce, and in order to leave the country, for a child to leave the country, he has to have permission from both the parents. It's funny, when I left Colombia, I was 16 years old. I was moving here with my mother, but I had to have a written letter from her saying that I could, even though she was with me. But it took my father a long time to finally say that, give her that letter. So I came here legally, but not with a green card. And my green card was actually pink, but in the 70s when they were first issued, they were green.
Right.
So I was a legal resident. So it turns out that you can serve in the military as a legal resident.
Yeah. Okay.
Right. So, if you just jump the border here from Mexico, they won't take you in unless. And then there was the challenge of my education. In Colombia, there's 11 grades, not 12.
Okay.
But you learn more because you learn less nonsense. So 11 grades. So my grades were from another country, and this recruiter did all the legwork. It turns out I lived in New York, so there was a lot of international things so my records got translated and all that. And then I went to this English as a second language school there was a free school for it was called Promesa. It means promise in Spanish, but it was an acronym for the Puerto Rican Organization to Motivate and Educate something. But I spent 3 hours a day there, and they gave me subway tokens.
Okay.
They gave me 2 subway tokens every day so I could get there and get back. It was 15 blocks from my house, so I walked, but I gave my tokens to my mom so she can take the subway to her work. So I spent 8 months learning proper English.
Okay.
I learned better English than most people learn in high school. And then, so I go to boot camp, the Marine Corps boot camp, and they speak a whole different language.
Oh, yeah. You learn some new words, is what you're saying?
Well, they speak naval
okay.
language, the porthole and the chow hole and the the deck. And for the first 2 weeks, I was just following people.
Okay.
Because I didn't know what they were talking about. And of course, there's the salty language.
Yeah.
I mean, back then there was salty language. I think they had to do away with that.
It's still pretty bad. My son went through, but maybe not as bad.
Maybe not as bad. So I learned English in school at a proper school, and then I learned English, Marine Corps English.
Yeah, and then now you're raising kids, so you have they have a different type of English as well.
Yeah, right. And then it was 7 years ago. I finally became a citizen. So as a legal resident, okay, as a legal resident, the only difference between a legal resident and a citizen is that you can't vote
in the U.S. election or any local.
Election. Wow, I mean,
they kind of
They're trying to change that, but that's another story. But that is the only thing. Yeah. As a green card holder or as a born or naturalized citizen, the only difference is you cannot vote.
Okay.
In any election. I mean, I pay taxes. I pay taxes just like you. There was no extra taxes on me. There was nothing. There was no incentive for me to become a citizen. Although I read something yesterday that says that when you graduate from Paris Island, you become an American citizen.
Okay.
I just happened to read that. I didn't look into it.
Yeah.
It may be fake news.
I mean, it makes sense to me. Like you should.
Well, a lot of people thought, and then I married an American citizen. So a lot of people thought that if you marry an American citizen, that automatically makes you an American citizen. That's not the case. You still have to go through all of this. Civics, you have to pass an American civics exam, which most people would fail anyways. And then you have to, they do a whole bunch of other background checks and stuff. But you still have to do it, even though I was a Marine, even though I was married to an American citizen, I still have to go through that whole process. And then, I got more interested in politics, not becoming a politician, but just in the politics. And I decided I wanted to vote. And so I became a citizen, and you can do it yourself. But if you do it yourself, you're going to screw up. So Chris, who was in 305,
right across the hall,
here, there was a lawyer who was in our building for a little bit, and he was my immigration attorney. Yeah. Okay. And he got me 2 months later, I was in Colombia getting my citizenship. I don't know if you know one of the guys from AAG.
Anish.
Anish.
Yeah.
He and I became citizens the same day.
Oh, nice.
A funny story about that. It was the same day the election in Port Royal took place.
Okay.
So my wife had invited all my friends to one of the Mexican restaurants in Port Royal. And when I walked in as an American citizen, everybody stood up and all my friends started clapping.
Okay.
So a lot of the people there thought I was the mayor, that I won the election for mayor of Port Royal. And for years, my granddaughter thought I was the mayor of Port Royal.
Oh, wow.
And she was really excited. She was really disappointed when she found out I wasn't the mayor of Port Royal.
Nice.
So that's
Yeah.
my becoming an American citizen story.
I mean, it was really inspiring to hear about that, and for me to see. I mean, this is a great country. You mentioned politics. I know I don't prefer not to get into that right now, but I mean, really, the thing that I mentioned is people. You hear about people in the state of our country, and it's not what people want it to be, this and that, but it's still a great country. You have so many opportunities, and it's a great place to live. I mean, we are, like you mentioned, we are blessed to live here, and that's really what I wanted to have, is like a conversation about what inspires you, what drives you, and so I think you've done a lot of that today, and to share with everybody. But was there anything else you wanted to share, just in general, about the inspiration, or just anything else?
No, well, as somebody who had, when something's given to you, maybe you don't appreciate it as much as if you earn it.
Mm-hmm.
So I feel I appreciate, I struggle when you ask me what do I tell my young self. I struggle with that because I've appreciated it. From day one, I've realized how blessed I am from the beginning. Quick story: when the plane, I'm in a plane from Columbia to JFK. When the plane touched down, the entire plane started clapping, like everybody. At the time, I didn't realize, why is everybody clapping, but at the time, I didn't realize it. Like, they knew they won the lottery.
Wow.
So, I mean, you remember when the Pope visits country, he always kisses the ground. These people felt that way.
Yeah.
The appreciation, it hit me later. I was 16 years old. I didn't realize the magnitude of that. But so now I appreciate it, and I'm not special. I just see it from a different lens, or through a different lens. How lucky we are. As bad as our people think our country might be, we're sitting here in front of this. There's thousands of dollars technology over here filming us. We have the luxury. We have the luxury of doing this. We have the luxury of, we have the ability to do all these things, and there's nobody stopping us.
Yeah, I mean, it's a great opportunity. You're an entrepreneur. You've raised a great family. You got a great wife, and you live down, and you've got a house, and you build another house, right? So you got a lot of cool things going on. I mean, it's really inspiring to me to hear about that, and just the opportunity. We didn't really get into much entrepreneurship aspect and business ownership aspect, but that's part of what you do too. And just starting a business and as I would say probably more of like a solopreneur, but you do have some people that work with you, right? I mean, you have some of your family helps and things.
Right. I try to keep it in the family. My son-in-law helps me. My other son, one of my sons helps me. My daughter helps me.
Yeah.
From time to time. But about that, I became an entrepreneur by accident.
Yeah. Wasn't planned per se.
It wasn't planned. I was working for another company. They let me go. And one of the architects who worked there, Bill Chambers, great guy. As I'm walking out of there with my little box of things, he walked out and he said, "You'll be all right, man. A lot of people respect you." And like a week later, I was in business. My phone was ringing a week later.
Okay, nice.
Yeah, so I've just been blessed because the opportunities have almost come to me.
Yeah.
And the opportunity's there. You just have to grab it.
Yeah, in terms of the business or just in general?
Just in general. You got to recognize this is an opportunity.
Yeah, in life.
Right.
Basically. Yeah.
Right. The best thing that happened to me was I got fired from that job. Best thing ever happened, besides, my wife and my children.
Yeah.
Of course. But yeah, it's getting fired. And
awesome.
So that door closed and a million doors open.
Wow, that's cool. That's cool. So that's encouragement. I mean, a lot of encouragement today.
I got a check. I got a severance check. I went to the Sprint store and bought me an iPhone.
Yeah.
Because I needed a new phone. That's the first thing I did when I got fired. Very irresponsible, but I knew that I was going to need a good phone if I was going to run a business.
Yeah, that's true.
Yeah.
Well, is there anything else you wanted to share with the podcast today?
No, I hope this thing takes off and then
Yeah.
we become legendary with episode 1.
Yeah, the legend, the man, the myth, Stoney Londono. Glad to have you today. I do have one more quick question.
Oh.
So, who do you guys play tomorrow? Are y'all playing this weekend?
So I
don't even know actually, but
the Clemsons play
the Clemson.
the Clemsons with a P play Georgia. It's like the big game of the weekend.
Okay,
the number 1 team in the country.
Yeah, we
Georgia.
got a rough game.
Against the 15th ranked Clemson Tigers.
Yeah, we're hoping we don't get too embarrassed, but
the South Carolina Gamecocks are not ranked, but they play. I don't know who they play.
Okay.
I don't get into the season until the season starts. I have friends who know who the third string quarterback. or who this recruit, and they text me like, "Hey, we picked up this guy," and I'm like, "Yeah, I don't know who he is," because that number 1 recruit hardly ever works out. We play. I don't know who we play, but in the worst of loopholes, it's the Sisters of the Poor.
Yeah.
Some Catholic college somewhere in the. It's either the Sisters of the Poor or some directional school. Southwestern South North Carolina.
Yeah.
But it's a small school. I don't even know who it is.
Well, hope the best.
But I'll be watching.
Hope the best for you guys. And
I'll be watching.
Thanks, Stoney, for joining us today. Everybody, we'll be back again with episode number 2. We'll have another exciting and inspiring educational podcast. So listen back for that one and take care, everybody.
Hey everybody, thanks for listening to today's episode of Enhance,